Welcome to our today's session on retrofitting approaches in the field of lignocellulosic ethanol. My name is Stephanie Hauschild. I'm working at the DBFZ in Leipzig, Germany, and it's a research center mainly focusing on biomass utilization and the technical, economical, and environmental assessment of biomass utilization processing routes, always with a focus on biorefinery and under the head of bioeconomy. And moderating with me today is Thies Fellenberg. He's from the ETIP Bioenergy Secretariat and from the FNR in Germany. And he is responsible for the technical support as well as for the Q&A session after the presentations. I'm very happy to have two experts in the field of lignocellulosic ethanol here today. Anna Susmosas from CIEMAT and Dario Giordano from Versailles. Anna is a researcher at the Advanced Biofuels and Bioproducts unit of CIEMAT in Spain, and her research focuses on simulation activities and techno-economic analysis of energy systems. She will give us an insight today into the Biofit case study of CIEMAT together with Biocarburantes of Castilla y León in Spain. And Dario Giordano is Green Chemistry Licensing Manager at Versailles. Versailles is a big, well-known energy or the chemical company of the well-known energy company Eni in Italy. And he's a chemical engineer and has long year experience in R&D management and IP management. And he will introduce us into the Versailles role on the lignocellulosic ethanol market and possible retrofitting options. But before I give the floor to the speakers, I would like to shortly introduce you to the background of this session and why we have organized it. So these are the speakers. And the session is part of a twin seminar organized together with the European Technology and Innovation Platform ETIP Bioenergy. And the first seminar was held on the 11th of November this year, so just 2 weeks ago. And I really hope you had the possibility to join the seminar because it was very interesting. It gave us an insight into the lignocellulosic process itself, some of them, their challenges, and also on the perspective or on the view of different companies on the situation on the actual market. But I think it's okay if you hadn't the possibility, because ETIP was able to record this session, so the recording is available on the ETIP Bioenergy website. This follow-up seminar is organized by the Biofit Project. It's a coordination and support action funded by the European Commission in frame of the Horizon 2020 program. And we, which are 15 different partners, are aiming to facilitate the introduction of bioenergy retrofitting in 5 different industry sectors. From one of it is the first generation biofuel sector. We have been producing different products until now. One of it is a map of already existing retrofitting examples in Europe, together with different fact sheets of best practice examples where you can have an insight on very specific details of the projects. And we have also written a handbook within the Biofit project where you can look up different technical options for retrofitting in different industries. And what we are actually working on are different sectoral and political recommendation papers. They will be published in the next year. So next to these products, we are also conducting different industry fora with different working group meetings where we want to exchange knowledge and experiences within the industry from different companies and market players and stakeholders. And we also want to support the networking between the industries and to gather feedback from them, how they see the situation, the market situation, and the situation of retrofitting. So in this framework, we have organized this seminar so that we can inform you about different technical options in the field of retrofitting. But what is retrofitting? Bioenergy retrofitting, in terms of the Biofit project, means the adaptation or replacement of, for example, an equipment, feedstock, or different side stream to foster the use of bioenergy instead of fossil-based materials. So we want to improve the overall sustainability of the process. If you see it in comparison to a greenfield installation, retrofit can result in lower capex, shorter lead times, faster implementation, therefore less production time losses and lower risk for the installer. If you see it from a plant operator perspective, retrofitting can provide the possibility to get rid of outdated technology or to energetically optimize the process, or even to generate new products or get into new sales market. So within this background, you have to listen to the presentations, and it is always good to keep that in mind. So I suppose you are all looking forward to the presentations, and I really want to introduce you to the presentation. But first of all, I have to just shortly name some organizational details. So the online seminar will be recorded, and all participants are muted at the moment. So during the presentations, you will have the possibility to ask questions after the presentations within the Q&A session by unmuting your microphone. But if you don't want to speak directly to the presenters, it's also possible to ask questions via the chat window on the right-hand side. The questions will be collected and then asked within the session. The presentation slides and the recording will be available online after the session, I think 1 or 2 days after, on our Biofit website. And for any issue after the session, please just contact me. I will try to help you and try to give you a solution. And now I think we are well prepared for our speakers today. And I'm very happy to announce the first speaker. It's Anna Susmodas from CMAT. I guess we are all excited to get an insight into the Biofit retrofitting case study. So Anna, the floor is yours.
Hi. Can you see my screen?
Yes, it works.
Okay. Shall I start?
Yes, please.
Okay. Good afternoon, everybody. It's a pleasure to be here in this seminar. Thank you very much for inviting me and giving me the opportunity to present the Biofit project. In this seminar, I'm going to to talk about this project, but mainly focusing on the retrofitting of the bioethanol industry. First, I would like to present very briefly the research center where I work. CIEMAT is a Spanish public research center belonging to the Ministry of Science and Innovation. Its research activities are focused in the fields of energy, environment, and technology, including sociotechnical aspects and in specific areas of basic research. In 2019, its human resources were 1,250 people. The annual budget was 88 million euros, and in the income generated by R&D activities was 29 million euros. CIEMAT has offices in several different regions in Spain, and its headquarters is located in Madrid. Now I would want to share with you some information about our unit, the Advanced Biofuels and Bioproducts units. These units belong to the Renewable Energy Division of Energy Department of CIEMAT. The main objective of this unit is the development and implementation of cost-effective technologies for the conversion of lignocellulosic biomass into liquid biofuels and bioproducts within a sustainable bioeconomic context. To fulfill this objective, the following tasks are addressed in our unit: hydrothermal and thermomechanical technologies for biomass pretreatment, hydrolysis of carbohydrates by biological catalysts, fermentation of the resulting sugar by microorganisms, and techno-economic analysis of energy systems based on lignocellulosic biomass, especially those focused on obtaining biofuels and bioproducts. And now, moving to the Biofit project, the main objective of this project is to facilitate the introduction of bioenergy retrofitting in the following specific industrial sector in Europe. An important activity of this project is to develop a specific case studies together with an industrial partner. In this seminar, I'm going to focus on the first generation biofuels, specifically on the retrofitting of first generation bioethanol industry. Before presenting the bioethanol case study, I would want to give you an overview of the bioethanol market in the European Union. This figure shows the evolution of the consumption and production of first generation bioethanol in Europe. In the green bars, you can see the production, in the gray bars, the consumption, and the dashed line shows the share of bioethanol in petrol. As you can see, in the last years, the bioethanol production and consumption increased slightly, and the share of bioethanol in petrol remains practically constant at 5%. And now we are going to see what raw materials are used to produce bioethanol in Europe. Nowadays, most of the bioethanol is produced from sugar and starch-based feedstock. In fact, in 2019 in Europe, almost half of the bioethanol was produced from corn, followed by wheat and sugar. This type of raw materials can be converted into ethanol using well-established technologies. However, concerns over the long-term sustainability of the first generation bioethanol, such as competition for food and feed production, impact on land use and water resources, have promoted the production of bioethanol from lignocellulosic biomass. And why bioethanol from lignocellulosic biomass? The main reasons are the following. First, lignocellulosic biomass is one of the most abundant renewable sources. In addition, these feedstocks are not linked to the food market, and many of them are residues, such as agricultural and forest residues, residues from agro-industries, organic fraction of municipal solid waste, etc. From a life cycle perspective, it usually represents lower CO2 emissions, and last but not least, it's possible to obtain high added value products within an integrated biorefinery concept. The necessity of the transition from food-based biofuels to advanced biofuels have been clearly recognized in the last energy policy measures taken in Europe. In the context of RED II, a 14% renewable energy target in is established, with minimum shares for advanced biofuels starting from 0.2% in 2022 to 3.5% in 2030. In addition, this directive caps the food-based biofuels to a maximum of 7%. Focusing now in the Biofit project, through this project we have been able to identify some opportunities for the retrofitting of the first generation biofuels facilities. First, policy are the main driver to promote the transition from 1G to advanced biofuels. Since advanced bioethanol production still presents uncertainties regarding its economic viability, the integration of 2G technologies into an existing 1G facility could be an excellent strategy to ease this transition. Finally, the integration of 1G and 2G technologies could result in synergies. Synergies such as the following. Taking advantage of the existing product distribution and feedstock supply and storage system, using the lignocellulosic parts of the sugar and starch crops, setting the purification areas, adapting the sugar content of the fermentation by mixing the mass, setting the general infrastructure, and using the lignin as renewable fuel or for high added value compounds production. As commented before, one of the main objectives of this project is to develop a specific case study for the retrofitting of first generation bioethanol facility, together with an industrial partner. In this study, the partner is Versailles Bioenergy. This retrofitting case will be compared to a reference case, which is the current situation of the first generation facility, an alternative case. In this case, an standalone second generation facility has been defined. In this slide, you can see the methodology used to address the case study. As you can see, the first step is the project description. Here, all the relevant information about the current situation, the retrofit case, and the alternative case are collected. This information includes data such as market situation, location of the facility, all the inputs and outputs. In this study, all the information regarding the first generation bioethanol production has been supplied by Versailles Bioenergy. In order to obtain the necessary data for the advanced bioethanol production, the retrofitting case and the alternative case has been modeled using process simulation tools. In this project, Aspen Plus was used for fulfill this task. Through this software, we can obtain the mass and energy balance for calculating the raw materials, the chemicals, utilities, and energy required. Once all the information are collected, the market assessment, the techno-economic assessment, and the sustainability assessment and risk analysis will be performed. This case study has been carried out together with the industrial partner Versailles Bioenergy. Currently, Versailles Bioenergy owns 4 bioethanol production facilities, 3 in Spain, in Coruña, in Salamanca, and in Cartagena, and another one in France. It has a total capacity production of 780 million liters of bioethanol. In addition to bioethanol, other valuable compounds such as animal feed, electricity, CO2, or corn oil are produced in some of the Versailles facilities. In this project, 2 options for the retrofitting of Biocarburantes de Castilla y León facility will be analyzed. In this facility is located in Salamanca, Spain, and in this figure you can see the facility of Carburantes de Castilla y León. This plant uses corn grain as feedstock and produces ethanol, DDGs, electricity, and CO2. Here you can see the amount of feedstock and products in 2019. This figure shows a simplified diagram of the production process of this facility. First, corn grain is screened and milled, and then is mixed with water and heated with steam prior to the enzymes addition. This process allows the conversion of the starch polymers into free sugars. Then these free sugars are fermented, producing a bioethanol-rich stream, which is concentrated by means of distillation, followed by molecular sieves, obtaining high-purity bioethanol. The remaining distillate is treated and dried, producing DDGS for animal feeding. In order to fulfill the thermal energy of the plant, this facility has 3 natural gas boilers, which produce all the required steam, and also has a gas turbine where electricity is produced. The hot gases from the gas turbine is used to dry the DDGS. As commented before, in this project, 2 retrofitting cases for the Biocarburantes de Castilla y León facility has been defined. In this slide, you can see the retrofitting case 1. In this case, a production of 11,000 cubic meters per year of advanced ethanol using an industrial waste rich in ethanol from a yeast production plant and wine alcohol are used as feedstock. In this figure, you can see that both feedstock are directly introduced in the ethanol recovery area of the first generation plant in order to produce high purity bioethanol. This case study presents low technical complexity, low CapEx, and therefore it could be quickly implemented. This slide shows the retrofitting case 2. In this case, in addition to the production of 11,000 cubic meters per year of advanced bioethanol from industrial residues, 19,000 cubic meters per year of advanced ethanol is produced from corn stubble. I mean, this case study is an integration between first generation facility and second generation technology. As in the last cast, the residual streams are directly introduced to the ethanol recovery area, and the corn stubble is first pretreated in an steam explosion unit, obtaining a water-soluble solid fraction called waste and a liquid fraction called prehydrolysate. The waste fraction is subjected to a presaccharification and simultaneous saccharification and fermentation process, producing a bioethanol-rich stream, and then is concentrated to around 50%. This stream is sent to the ethanol recovery area of the first generation plant, producing high purity bioethanol. The remaining second generation distillates and the prehydrolysate fraction are used together with the first generation distillates to produce DDGS. As you can see, this process presents higher complexity and presents also higher CapEx than the case 1. In this slide, you can see the alternative case. In this case, a second generation plant for the production of 30,000 cubic meters per year of advanced ethanol from corn stubble has been proposed. In this case, you can see that the corn stubble is pre-treated in an steam explosion unit, obtaining a waste fraction and a prehydrolysate fraction. The prehydrolysate fraction is first concentrated and then subjected to a detoxification step, and finally is fermented, producing bioethanol. The waste fraction undergoes a pre-saccharification and simultaneous saccharification and fermentation process, obtaining bioethanol, and then both stream are concentrated by means of distillation, followed by molecular shift, obtaining high purity bioethanol. In order to analyze this case study, the following indicators have been defined. First, a technical indicator which include the increase in biomass converted per year and the increase in the biofuels generated per year. An economic indicator which includes the internal rate of return and the CapEx reduction compared to the alternative case, and an environmental indicator which includes the CO2 emission reduction and the increased efficiency of resources consumption. Regarding the technical indicator, it is important to know that the main objective of this case study is to reduce the food-based feedstock. I mean, the total production capacity are the same in all the cases. As you can see, in case 1, around 20,000 tons per year of corn are reduced using industrial waste and wine alcohol. In the case 2, around 70,000 tons per year are reduced using also corn stover. Regarding the economic indicator, the economic assessment is still in progress. Some preliminary results are the following. In this case, better results are obtained for case 2 than for case 1. This is due to because in the case 2, I mean, in the case where corn stover is used, more DDGs is produced. These results highlight the importance of producing valuable co-products for the profitability of the bioethanol production process. And regarding the environmental indicator, this assessment is also in progress. Finally, through this process, we have been able to identify some market benefits that can be obtained and important policy recommendations to promote the retrofitting of the first generation facility and also the use of biofuels. The main market benefits obtained are the following: reduction of food materials for energy purpose, promoting advanced bioethanol in the short-medium term, increasing the value chains of residual feedstocks, and diversification of feedstock. Regarding the policy recommendation, it is important to highlight that the European biofuels installations are fairly new. For this reason, costly investment in retrofitting measures may seem early from a plant operator's view. In addition, biofuel sector is heavily influenced by regulation. So the high risk of change of regulation hinders investment in the biofuel sector. It could be important to put dedicated biofuels products at the pump. This measure allows customers to choose sustainable fuels. And finally, the CO2 emission of the different fuels should be also visible to the customer at the pump. For more information about the Biofit project, you also can visit our webpage. For my side, this is all. Thank you very much for your attention.
Thank you very much, Anna, for this very interesting insight into the Biofit case study, as well as the introduction to the ethanol market situation, which is very interesting and important at the moment. I'm sure that there are some questions in the audience. I just want to remind you, questions are always welcome within the chat, and then we will have a Q&A session at the end of the session, or at the end of this workshop, where you can also unmute your microphone and ask the question directly to the speaker. But now let's dive directly into the next presentation from Dario Giordano. Dario is working at Versailles, an Eni company, and he will give us an insight into the activities of Versailles in the field of lignocellulosic ethanol and retrofitting options in this field. So Dario, the stage is yours.
Okay, thank you very much. And let me just share the screen. And let me see if, can you see my screen?
It's fine, yes.
Okay, great. Okay. Just try to put the presentation mode. Can you see the screen in presentation mode now?
Yes, perfect.
Okay, great. So, first of all, thank you for giving to Versailles the opportunity to talk to this event, and it's for sure a pleasure to bring a little bit of information about the process technology and what we are doing. I think that our role in all this kind of seminar is to give you an industrial view, also thanks to the experience that we made in commercializing the process technology in our Crescentino plant. And so bring at the table the experience that we made in this journey. But before I start, let me go through this first slide, trying to introduce a little bit Versailles. Versailles, as was mentioned, is part of Eni and is the chemical company of Eni. We have several business units, and you can see mentioned the name here in the top part of the slide, that are directly related to our traditional petrochemical business. But since 2018, when Versailles acquired the bio business of Mossen Ghisolfi Group and combined all the bio effort in a single business unit, there is a business unit called Biotech that is entirely dedicated to development and operation of biorefineries. We have two biorefineries in Italy, one located in Sardinia, that is based on oil, and the other that is located in Crescentino, that is based on biomass, and both are operated under the same business unit. On the left side of the slide, you can see what is the industrial footprint of Versailles. Is a company that is about 5 billion euro turnover and is about 5,000 employees around the world, and it's characterized by a large presence in Europe and with a number of R&D centers that are dedicated to support the different business. 2 of our 6 R&D centers are entirely dedicated to support the biotech development. To move next slide. Oops. Can you see the next slide or?
Not yet. Maybe try to close the presentation mode for a second and then open it again.
Okay. So that's when in this slide there is a footprint of the licensing capabilities of Versailles. I think when Versailles acquired this technology, there was 2 major objectives. The first one is, of course, indicated in this slide. Versailles is a well-established licensor of technologies. Versailles has a portfolio of multiple technologies in the traditional petrochemical business, and traditionally is licensing to throughout the world the technology that are used in their industrial plants. So Proesa was a perfect fit for within this structure and this strategy, because it's a technology that is operated at industrial scale and that can be licensed worldwide. And so one of the driving reason for Versailles of acquiring this business was for sure to implement the technology portfolio that is available for license. But the second and also very important reason is that this technology perfectly fit within the strategic drivers of our company, and not only of Versailles, but generally speaking of E&I. So in the different areas of our company, there is a increasing activity in the area of circular economy, and these activities are touching different fields, going from, of course, chemicals and design of innovative solution that can allow better recycling, better eco-design of feedstock diversification, is going towards remediation and renewables, is going towards the green conversion. So we are operating also in our regular oil business, biorefineries. We are producing green chemicals, so chemicals that are based on biomass and not derived from oil. And of course, a major attention is given also to advanced biofuels. And because of the need of decarbonization of the transport sector, this is an area in which we are spending a lot of energy, and that is the perfect fit for Proesa technology, because it can be the technology to produce a few advanced biofuels today, so cellulosic ethanol, but is also the right platform to produce advanced biofuel tomorrow in the form of other kind of oils. So with this in mind, you can understand that Proesa is a technology that is perfect for bio-run chemical plants, and this has been the main thought behind all this development, and has been continued in Versailles after the acquisition of Proesa technology. This slide, in a very simplified format, is representing what Proesa can do. So basically, can transform non-food biomasses into cellulosic ethanol or other product that might be derived from sugar fermentation, from cellulosic sugar fermentation. Products that can enter into the chemicals and material chain, or can be other biofuels. And I think that what is very important is that this technology is based on non-food biomass, and so can really decouple the production of advanced biofuels and chemicals from food-related issues. The technology is the result of a development that has been carried over since several years, started by M&G back in 2006 and continued now by Eni after the acquisition that happened at the end of 2018. This technology development went through the traditional steps of any development, going from lab up to pilot scale. But what is the real characteristic of Proesa technology is that the technology has been already deployed at industrial scale. And this deployment that went through a number of difficulties and technical challenges that are typical of this kind of scale up, at the end results in improving the viability of the technology, and was a real area of learning that now can be implemented and in the next projects, and can be used to de-risk any future industrial investment. And the characteristics of the technology are briefly reported in the bottom part of the slide. One of the key elements is the versatility of the technology in the use of different kind of lignocellulosic biomasses. And the biomasses that I mentioned here, so wood chips, energy crop, and agricultural residues, are not only being tested in the development and in different phases of the development, but all of this category has been run and operated at the industrial scale in Crescentino, at least for days of run. So that is very, very, a very peculiar point of Proesa technology. The development has been done in cooperation with the leaders in enzyme and yeast, and today Versailles is in the position to offer a technology package that can include all the solution in order to de-risk the fermentation and the enzyme used in the process. And this is done through very strong partnership with very large companies, and can include solutions that encompass production on site of enzyme or delivery of enzyme from externally produced site. So really we can match the requirement of our customer according to the specific need. Of course, the technology is backed by a very strong IP and by the continuous development that is carried on by Versailles, that, as I said, is the largest chemical company in Italy and one of the largest in Europe. This is a very brief snapshot of the technology. I think is a very well known scheme, representing almost all the technology that generate second generation ethanol from biomasses. Just a couple of key points of our technology. We are not using chemicals in the pretreatment and in biomass cooking step. This is a step that is entirely designed by the owner of the technology, and allow to process the biomass without the need of chemicals. The other very important point is that the lignin coming out of the plant is a very clean lignin, and this allows to see a lot of avenues for Lignin Valorization, and that is one of the areas in which Versailles is very advanced and is sharing information with its licensee. Here you can see a picture of the site that I mentioned before. This is where the technology is applied. Is an industrial site. Is about 10 hectares. Is the surface of this unit. Is using several kind of biomasses. As you know, in this period of pandemic, this plant has been converted for production of sanitizer, according to the request of the Italian government. So Versailles has made some changes in some of the production unit and used most of the plant for the production of hand sanitizer. Plus, this plant is equipped with the green electricity generation and the biogas generation that are in operation. So we have also served and used the site to support the Italian country during this very difficult period of pandemic. So really, I will go now through some example that we are studying. Again, will be very simplified example, because we are looking at opportunities like the one that we are presenting with a number of different players in the industry. But I will give you some of the ideas that we are presently discussing in the market. Of course, behind this idea, there are the some strategic drivers that normally are both in the direction of having a more sustainable development and a transition towards renewable, in line with the, of course, the way to the greener approach, and also, of course, an opportunity for business diversification and profitability enhancement. And clearly, what is the center of all this is the biomass valorization, and really that is one of the things that is really the center for this possible retrofit. The first example is an example of a biomass power station. There are developed in Europe because of different kind of support for the production of green power, different power stations that are based on biomass. So a biomass power station has a very good opportunity because already control the supply chain. Most of the time the supply chain is based on wood chips, and one of the characteristics of our technology is that we prove to be capable of working with wood chips. So easily someone that has a wood chip a biomass power station can take and have this control of the biomass supply chain to produce both green energy and ethanol. So you can think to have a scheme like this one. Someone that has a biomass power station can use the biomass into a Proesa unit, and out of the Proesa unit he will get the second generation ethanol that he can sell as an advanced biofuel in the European market, also taking advantage of the RED II regulation and the premium that this regulation will generate on the market. And we'll have as a byproduct the lignin that, as I said, is a component that is coming out of the plant in solid form, a different level of humidity that can be adjusted according to the requirement of the power plant. And this lignin can substitute a portion of the biomass. Of course, depends the mass balance on the size of the biomass power plant, up to all the quantity of the biomass that are used for the production of green power. And this is a kind of setup that can allow the producer of green power based on biomass to diversify the business, and also to leverage the existence of a biomass power plant to reduce the investment of a second generation ethanol plant. Another example that we are exploring is greening the coal power station. There are coal power stations in Europe that are requested to reduce their CO2 footprint, and in order to be kept in operation. And this can be a good way to take the lignin coming out of an ethanol plant. Also, in this case, allowing to reduce the cost of the investment, the capex of the second generation ethanol plant. In this case, the difference is that usually this kind of companies that are dealing with fossil-based fuel have not the experience in the biomass supply chain. So in this case, will be necessary to develop a specific and dedicated supply chain for the second generation ethanol. So that is an additional complication that the biomass power plant case that we have seen before have not to face. The other case that we are studying is pulp mill. There are, as you know, the pulp mill are very good in handling the wood supply chain. They have large capabilities for management of wood resources in a sustainable way. and they are also handling a lot of residues. And so far, the pulp mill have been a little bit outside the discussion because there were very little experience on wood chips. Thanks to the fact that Proesa is working very well on wood chips as well, we have started discussion also in this field. And what a pulp mill can think is to leverage on the existing infrastructure, because a lot of the units, including wastewater treatment and utilities production, can be shared with the Proesa plant, and so this can reduce the overall investment. And of course, a pulp mill can leverage on the capabilities of not of the existing asset, but also on the existing capabilities of managing the supply chain in order to diversify the production, and also try to compensate on the fact that the paper market and the pulp market is, of course, under a lot of pressure, diversifying in new products that can come out of the Proesa unit. And they can see the lignin as well as the ethanol as the product coming out from the biorefinery part. As one additional and last example that I like to bring is the one that has been already discussed by the other speaker. But I like to share our view as well on this area. Of course, the first generation ethanol producer are, according to our view, a key player in this development of the market towards advanced biofuel. They know all the customers, they know how to produce ethanol and to market ethanol, and moreover, they have the contact with the farmers that are producing the crops that are fed in their plant. As we have seen in the graph before, in Europe is mostly corn and a little bit of wheat. But these farmers that are producing the crop are also producing residues. And clearly, the residues that are produced in the field, like the corn stover or the wheat straw, can be collected, and the same farmer can deliver to the same plant at this point both product. From one side the corn, and the other side the stover. From one side the wheat, and from the other side the straw. So really the advantage for the first generation producer is the fact that they can already have the contact with the supply chain. Installing a Proesa technology close to one generation ethanol plant, of course, will offer a number of opportunities for integration. The integration can be at different level, depends really on the configuration of the first generation ethanol plant, the capabilities of the fermentation and the distillation of first generation plant, and how much you might want to reduce first generation versus second generation. So really it's difficult to have a simplified scheme, because of course the integration will require some technical work. But basically a first generation ethanol plant can think to either increase or diversify the production, and also will have the opportunity to have a new material to put on the market, that is the lignin, that can be an additional product. So I think this is very interesting, and we have seen in Europe an interest for this kind of setup, and we are discussing how we can implement this at industrial level. So I think this is covering the different options that we are presently exploring at different stages in the area of retrofit. Of course, this is going in parallel to the major activity that Versailles has in studying projects for new plants that will be, of course, greenfield plants or brownfield, but with no real co-siting opportunities. So that is ending my presentation. I thank you for the opportunity, and I share with you this last picture of our industrial plant, and I'm at disposal for the question that you might have. Thank you very much.
Thank you, Dario, for this very interesting presentation. And this, it's very good to have this industrial view in this session, as you said. And I just click that. And it's good to know more about the Versailles investigations within this field of retrofitting options. So we got a lot of information during this session, and I'm pretty sure, or I think there might be some questions from the audience. So I will hand over the word to my colleague Thies Fallenberg, who's going to moderate the Q&A session. Thies.
Yeah, thanks a lot, Stephanie, and also thank you from my side to the speakers, Anna and Dario. So the first question goes to Anna, and the question is how effectively the ligneous components can be separated from the main material stream flow.
Hi, thank you for your question. In this case study, the lignin fraction is not separate. It remains in the lignin fraction, in the styrene fraction, sorry.
Okay, thank you for clarification. Then two questions to Dario. The first one is concerning the plant in Crescentino. So is it operative already today?
The plant has been put in operation, but as I said, today we are producing both the green energy and hand sanitizer. So it's not producing cellulosic ethanol. We were planning to start production, and we had done all the work to do so by middle of this year, but then we are in the middle of the pandemic and we have to reschedule everything. So in 2021, the plant will restart production of cellulosic ethanol, and of course the plant is going to be ready to do so. The issue is what is going to happen with the pandemic, because being the largest ethanol plant in Italy, we have been requested by the state to produce hand sanitizer, and we are using the plant to produce hand sanitizer in this moment. Really, the intention is to restart. I mean, the plant has operated many months in the 2016-2017 time frame. We've done all the necessary maintenance. Really is a matter of understanding the situation of the pandemic. There is no other thing that stop starting the production.
Okay, thanks a lot. And the second part of the question was if you can say some words about the pre-treatment that is currently used, and what kind of technology are you using for the lignin separation?
Okay, for the pretreatment, as I said, is a steam-based pretreatment that is has been developed, and you know, all this kind of technology has a very complicated path, because the pretreatment is a very critical step in these technologies. During the development, there have been development of machinery and equipment that are specifically designed in order to process the biomass, and this has been applied, used, and operated in Crescentino. And so now, when we are offering the technology, we are basing this design not on a third-party package that, you know, you buy a third-party package that has never operated an ethanol plant is risky. And but we are basing the design of a series of process equipment that has been operated in Crescentino after that has been properly developed for that process. So that is our approach. Really, we are licensing this technology and this part of the technology with the same approach you do for other industrial processes, in which you have a process design with some of identified vendor for some specific equipment, but there is no packages that you buy from someone. And the second question was about lignin separation. You know, lignin is separated at the entering of distillation section, and is in a water slurry as a solid. Once that you are at this point, there are several options that you can apply. We have a couple of options that we prove at the industrial level that will deliver a different level of moisture content. And that's really depends on the following step that you need to achieve, because also the, I would say, the physical aspect and the properties are slightly different. So we can apply these technologies, but these are technologies that are available on the market. It's more the learning how to implement this at the industrial level. So there is more trade secret than other in this part of the plant.
Okay, thanks a lot, Dario, for clarification. Another brief question that was raised in the chat box for Anna. So when will the final results of the study be available? Is this already be predictable?
Okay, at the moment, the economic analysis is almost done and the environmental analysis is starting. So I don't know exactly when the all results will be published. I suppose at the end of the project, all the results will be published, but this is last year. It's in October of 2021, but I suppose that it can be published soon.
Okay, thank you. Another question that just came in now for you, Anna, as well, is, are you going to evaluate the total retrofit of the existing first generation refinery into a second generation only using lignocellulosic residual biomass?
No, at the moment, no. In this moment, only we considered the retrofitting of a part of the facility, not to remove all the of the food-based feedstock, only a part of it.
Okay, thanks a lot. So all questions that were handed in via the chat box, I think, are answered then by the speakers. As mentioned by Stephanie at the beginning of the webinar, so you also have the possibility to raise your questions just live by unmuting yourself, which you can do by yourself. So if you have any questions or would like to give any comments on the presentations that we just heard, so please feel free to unmute yourself and raise your question here right at the spot. Okay, this is not the case for the moment. And there's also no other questions. Okay, one more question that came in for Dario. Are you producing some commercial components from the lignin separation besides input energy to the entire process?
Of course, as I said, in this moment we are not producing, but we have done a lot of work, and we have a couple of applications that will be used to sell the lignin into. We are in the process of patenting such applications, so I cannot be more specific. But generally speaking, I can say that the the lignin valorization is one of the key topics for us because in operating this unit, we have handled this material. We know how this material is coming out, and we know that valorizing the lignin will be a very, very important step for biorefineries economy. So, I mean, we are really investing a lot of resources in this direction, and we start to have some very interesting results. And that is one of the areas which Versailles is dedicating a lot of resources.
Thanks a lot. So since there are no further questions coming in for the moment, well, I think the participants also have the chance to hand in the questions afterwards and direct them to Stephanie, who will forward then your comments and questions to the speakers. So thanks a lot for your presentations and your remarks. So I would like to hand over again to Stephanie then.
Thank you very much. Also from my side, thank you very much to the speakers. Thank you very much to Thies Fellenberg for your support, and also to the audience. I think we heard a lot of information about lignocellulosic ethanol and the possibility to retrofit different plants in connection with that. I think not only from this session, but also from the session of ETIP, we learned that ethanol should not only be seen as the only product of an ethanol plant. It is always, we have to consider refinery concepts and think about the use of different side streams and different products. But we also heard about the challenges of second generation ethanol and the barriers or the drivers to support retrofitting in this field. We heard about solutions, about the investigations of especially Versailles, and also the project work of CMAT within the Biofit project. And I'm very delighted that there are these projects, and there are still companies who are interested in this field, who put effort in this field, and who wants to take the next step. And I hope to hear a little bit more in the near future about the investigations of Versailles. Would really much looking forward to that. So yes, as I said at the beginning, this session was recorded, and I hope it will be is that you will take the chance to advertise this record as well at your companies. So I found it very interesting, and I'd like to thank the speakers, and I think I will wish you a pleasant evening.